Okay, so now I'm going to talk about two important facts which are going to play a role later on in our course. The first is that I can express the number 1 as a fraction by writing a fraction with the same numerator and denominator. So for example, here I have it. A fraction with the same numerator and denominator represents the number 1. In other words, it represents a whole. For example, if you look at this pie here, we can imagine it's apple pie. It has been sliced into these 3 pieces, you see. And if I shade the whole thing, I'm shading 3 out of the 3 slices. That is to say that the fraction 3 over 3 represents the whole pie. Or in other words, if I had 1 pie, 3 over 3 also represents that 1 pie. Right? Okay. So to recap, this one fact says that if I want to express the number 1 as a fraction, I write a fraction with the same numerator and denominator. Yes. Just to give a preview of where this is going to play a role, although it might not make sense right now, is in multiplying fractions. We know that if I multiply any number by 1, I get the same number. 5 times 1 equals 5, 3 times 1 equals 3, 100 times 1 is 100, and so forth. And this is the idea of where this first fact is going to play a role. Okay, now the second fact is as follows. I can represent any number as a fraction by setting it as the numerator and setting 1 as the denominator. For example, I can set the number 3 as a fraction by setting 3 as the numerator and 1 as the denominator. I can set 5 as I can represent 5 as a fraction by setting 5 as the numerator and 1 as the denominator. Okay? Now, this is going to play a role in showing how mixed numbers can actually be converted into an improper fraction. That's where this fact is going to play a role. And it will also come out in later in other areas, but that is one of the main places where it's going to come out. I do want to make a little note here. It's a little technical. It's not really necessary for the purposes of our discussion. But I do want to point out that I am not saying that all numbers can be represented as fractions just by setting them as the numerator and setting 1 as the denominator. This is a rule basically that has to do with performing calculations with fractions and not necessarily with the underlying form of the number. For example, there are certain calculations where I might want to add square root of 2 plus some fraction, and I might be able to combine them so that they're that it looks like a more compact expression, and I might apply this rule. But that is not to say that, for example, the number the square root of 2 is actually equal to a fraction. Okay. But this rule is being stated, this fact is being stated for the purposes of calculations that we're going to perform, and we will see that shortly. Thank you.